Hi, class. I'm sorry I can't be with you today, but I'm there in spirit with you. So today you're going to learn about Chapter 23, Forces and Fluids. As you can see, we're going to be talking about pressure in this first section. And your first definition that you need to know is the force per unit area that is applied to an object. And that definition is called pressure. So as I'm filling in on my paper, I'd like you to also be filling in on yours. The next sentence says, depends on the force applied in the area of contact. So let's think about, while we're thinking about pressure, it is a dance floor. Okay? So we've got a dance floor. And that is simply an area, right? An area that we like to dance on. And the next sentence says, pressure increases if the blank applied increases. So what blank goes here, the word that goes here is force. So if we increase the force, the pressure also increases. Now let's take a look at our next sentence. It says the pressure decreases if the area increases. And the way that we can think about these two words is like this. So we have a dance floor and we have two ladies that love to dance. We have one lady that likes to wear high heels. So you can think of someone that you know that loves to wear high heels. And then maybe perhaps we have another woman that prefers flats with maybe just a little heel. So the area that we're talking about, if we're talking about this sentence right here, the pressure decreases if the area increases. If we're talking about this lady right here with the heels on, she has a very small area that comes in contact with the dance floor. Because of that, her pressure will be high. So she will have high pressure. Oops. This woman with the very low heel will actually have very low pressure because of the area that the shoe is in contact with the dance floor. You can also think of it like this. When you are dancing or you go outside, I take that back. If you go outside and you walk into the grass, your heel is always going to sink into the mud or the grass or whatever floor you're dancing on. When that happens, that's because you have very high pressure. All of your weight is being distributed just on this little bitty area right here. Whereas if you're wearing flats, the surface area is being applied to the whole shoe, and therefore you have very low pressure in this instance. Okay, so let's look at the formula that we use to describe this. The formula that describes pressure is force divided by area. It's abbreviated P equals F over A. And we need to know some units of measure for this as well. The unit of measure for force, which we know is the newtons, can be abbreviated with an N. The area is meters squared, or M to the power of 2. We have pressure, which is Pascal, which is abbreviated PA. Now, you will remember that one of the things we learned last chapter, that 1 Newton equaled 1 kilogram times meters per second squared. And that was just something we had to memorize. Well, this is something also that you have to memorize. It's the same principle. 1 Pascal will equal 1 Newton meter squared. So we're going to look at some practice problems to help us understand this. Our first practice problem says, a water glass sitting on a table weighs 4 newtons, and we're remembering our formula, F equals ma. The bottom of the water glass has a surface area of 0.003 meters squared. They would like us to calculate the pressure the water exerts on the table. So let's look at our given. That's the first thing that we're going to want to do. All right, so we can identify 4 Newton. So we know that that is force. So we'll identify it here. It's telling us the surface area. So here's our little hint here. Area, and area is used with a capital A. We don't want to get that mixed up with acceleration. Is being 0.003 meters squared. Once we identify our given, we have to write our formula. And our formula is pressure equals force over over area, force over area. We plug in our given, so we're still looking for pressure. Force is Newton, and the area is 0.003 meters squared. Once we use our arithmetic in our calculator, which you should have out on your desk, and you do the division, you find that pressure will equal 1333 Newton meters squared, or we can say pressure equals 1,333 pascals. Again, these two are identical, they're equivalent. Let's look at another example. It says a student weighs 600 newtons. There's our given, force equals 600 newtons. The student's shoes are in contact with the floor over a surface area of 0.012 meters. Calculate the pressure exerted by the student on the floor. So we have identified our area. We plug in, and I'm sorry here, I forgot to put in my formula. Let's see if we can give us some space here. There we go. Our formula is P. Our formula is, let's see what happened to my pen here. My formula is